Hi, I'm Dean Bushmiller with Expanding Security, and this is Machine Learning Principles and Practices. I know what you're saying. You're saying, Dean, you're late to the party. Everybody else is talking about machine learning principles and practices. We're talking about it from a cybersecurity standpoint. Not any other way of looking at this should even be on your mind at this point, because there's plenty of other people, you're right, that can go ahead and talk about it in other ways. And I'm actually going to talk about a couple of people who really know what they're doing when it comes to learning machine learning and learning how machine learning is going to be deployed. My focus is going to be on cybersecurity and how you can incorporate this into your organization. So generally, first off, we have to decide whether we should do this or not. You know, the kind of the why or the why not of any of this stuff. When I look at it, I go, okay, let's look at the bad things that have happened so far and the good things. So first off, in 2024, Ford said, hey, let's get rid of these engineers. AI can do all of this stuff. Recalls went up, quality went down. It cost them $4.8 billion per year. And specifically, they had one recall incident that cost them $570 million. We made a mistake. Yeah, not only that, but their shareholders lost 9% of their stock value in years when the Standard & Poor's was up by 70%. So it was really not a good thing for them. The only way that they could recover from this is going back and rehiring those graybeards again. So they've slowly dug themselves out of this hole. Okay, let's look at it to the positive side. Walmart, retail and logistics for them. They have supply chain and inventory management problems. Well, everybody in the retail business has a supply chain and inventory management problem. How do we solve it? Well, one of the things that they wanted to do is they wanted to redirect overstock shipments without any human intervention, because it's really expensive to say, oh no, that doesn't belong there, it belongs here. They saved about $55 million. And more importantly for them, if you've ever been in the retail business, they have this thing called the holding inventory. And they capped their holding inventory growth to 2.6%, which is really good because that compounds year over year over year for them. Okay. So we've got a good example, we've got a bad example. Where do you fit in all of this? First off, the magic. 75% of the gains from AI are captured by 20% of the companies that are out there. And I hope you're one of them, but we can't just say, oh, well, we're going to fit into that specific place. Okay, no. Okay. In order for us to win, for you and I to win, we have to learn the limitations of and uses of AI. I've been learning that over the past couple of years. Understand how AI applies to our business and also where it doesn't apply to our business. And lastly, realize that there is no magic wand out there for AI. It does not exist. So we have to prepare and we have to understand exactly what's going on with machine learning and AI. When you're listening to me in this process, I'm going to talk about AI, machine learning, and I'm going to kind of bounce back and forth between the two of them. I know that they're different things, but we just want to go ahead and have a little bit of variety in the way we say things. Are you buying AI or are you building AI for your organization? Most of us are not building large language models. There's an exception to that, but we're going to stay away from that. So if you're a model maker, you do one set of practices. We will talk about those practices. If you're a model consumer, you kind of use the models like they do. I mean, I've got my internal models, Dean. Yes, I am a model consumer, but where does the line end for us? Well, I look at it and say, okay, if you're doing RAG, which is retrieval augmented generation, and that really is about fetching the facts from your mission specific data, your knowledge base, your databases that you have, fetching that and combining that with a large language model, you're a consumer of models. You're going to build like you're a builder of models, but you're a consumer of it, and you have to consider anybody who builds models. You have to decide as a vendor of yours how you're going to trust them. So therefore, that means that you need to learn how they build things. And that's why I'm going to switch back and forth between as builders or as buyers, as builders or as consumers. So be looking for that as we walk through the presentation. It's your job to know both sides of this. Okay, so which new model are you building? I'm going to assume that you're a builder at this moment in time. You're probably building large language models. That is a next word predictor. But there is another type of model that's out there. This is called the world model. Sometimes it's called JEPA. It's Joint Embedding Predictive Architecture. It predicts the representations of the world. The difference between the two of these is that JEPA understands the consequences of its actions and large language models don't. You say, well, Dean, why don't we go ahead and go to the consequences side of things? Why don't we do that? Because most of what we do is language-based and language-bound, so therefore the large language models work really well for this. It's interesting, if you actually look at JEPA and you compare it, even in its infancy right now, what it does better is predicts how video is going to play out over time. So I think in the future, JEPA is going to kind of take over the video area for us because it has a lot lower cost of consumption. When we talk about machine learning, we're thinking about algorithms learning statistical patterns from data. The real world uses for us, if you've never talked about AI or never understood where it's coming from, our real world uses are things like spam filtering, fraud scoring, and yes, I am talking along the cybersecurity side of things. Malware classification, recommendation engines, which is more on the marketing side or the retail side of things, document classification, which will work really well, and anomaly detection, which is excellent in cybersecurity. If we look at the paradigms, there are 3 machine learning paradigms under which we work. That's going to be supervised, unsupervised, and reinforcement learning. So we're going to compare those 3 and see how we'll use them. When you're choosing models, what you would say was this supervised learning, unsupervised learning, or reinforcement learning, and when would one be good over the other? On the supervised side of things, the model's trained on labeled input and output pairs. This is a cat. That is a dog. The algorithm learns mapping the features to known targets. This could be fraud or not, or this is a dollar amount this thing is valued at. This dominates the whole production machine learning that's out there. And that's because labels enable direct error measurement. You're right, you're wrong. That's not a cat, that's a dog. And most business problems that we're working with are labeling problems that we run into, like spam filtering and malware classification. Okay, so why do we use supervised learning paradigm? Well, we want to default to supervised learning when labels exist or are cheap to acquire. You have a lot of labeled data within your business, but it has to be really small labels there. Okay, well, why not use supervised learning? Well, the classic failure mode is label leakage, where the model in training, that's the target model that's in training, sneaks into the features and learns things. And then what happens is the model collapses on new data. It's a weird looking cat. It's a hairless cat. It goes, I don't know, what's that, a chupacabra? I don't know what that is. Okay, we go from supervised to unsupervised. The algorithm finds structure in unlabeled data that's out there. This is done through things like density estimation, clustering, or dimensionality reduction. So why do we use that labeling? Well, the unsupervised. Well, see, security teams use this more. We're security people. You're a security person, right? Okay, you use this more. When we think about attacks that are out there, they are always new. They are always unlabeled. If we've got a signature database on that, that's great. If we have a signature on it, probably we can defend against that particular thing. And we have a lot of normal data. This is what normal looks like. And we can train on that's what normal looks like. Anomaly detection is not normal. So when we're processing lots and lots of data and it's flowing through and it looks all normal, we go, okay, well, this one doesn't look normal. Okay, we're going to put it over there. And so for security people, this is a really good thing. Unsupervised output is lead generators for analysts that are out there. Because right now, as security operations centers, we have lots and lots of false positives, and what we want to do is we want to reduce the overall false positives. We may not be able to see that this is normal data because it looks a little abnormal to us, but when we have large amounts of data, this works out really well. Okay, when shouldn't we use unsupervised data? And this gets to the quantities of data. It requires very large quantities of data. I put in here 1 million data points, greater than 1 million data points. I'd really like to say greater than 10 million or 100 million data points. That's kind of what we need in order to make these systems work well. I don't think normal businesses, anybody outside of the Fortune 1000 or the Global 1000 businesses, I don't think that we have 1 million data points to put together. So therefore, we might have to look to larger vendors that are out there. We'll get to that in a little bit. What about reinforcement? Reinforcement learning. An agent learns a policy by acting on a particular environment. They want to maximize their cumulative reward. They want to be, you're a good model, right? The paradigm that we see this in is like AlphaGo or reinforcement learning from human feedback. That's RLHF. God, I can never say that one right. This is where we do a lot of fine tuning in models, and this can help us out. We can actually use a stock model and do fine tuning on it for ourselves, giving it more information. The important thing here with this one is this matters whenever sequential decisions compound over time. Like modern chat. Hi, I'd like to talk to you about my failed pencil that I just purchased. And then what happens is the model goes, okay, we're not going to talk about anything but pencils. We have erasers, we have stationery, this is a pencil problem. And it eliminates all that stuff. Okay, what kind of pencil do you have? Is it a wooden pencil or is it a mechanical pencil? And then it divides and divides and divides. And we're working through this alignment here. Or it could be something like an autonomous response playbook. How would we do this? How will we do our incident response? Kind of like decision tree kind of stuff. It also works really well in scheduling, resource scheduling, because it is linear in nature. Once this thing happens, then this thing can occur, and we can map that out in our structure. Why do we use this learning paradigm? Well, it might be that supervised learning is failing. It could be that, right? Okay, why not use reinforcement learning? There's this odd thing that happens, which called reward hacking, is a signature failure. What happens is in agents, they say, that's a good agent. You've done the right thing. You're a good model. You've got the right thing. But what can happen is if we don't clearly define what's going on, the agents are going to game the system. They're going to go after badly specified rewards and kind of route around us to go ahead and get to the prize. And so we don't want to use it in those cases. That means that we should have been specific up front about what our objectives were. So I know what you're saying. You're saying, Dean, you got me so excited about all this stuff. I want to learn to build large language models. That's not this class. But actually, Sebastian Roszak, and if I've said his name wrong, please forgive me because I've watched his entire course on YouTube. He's got something called Build a Large Language Model from Scratch course. It's about 8 to 20 hours. I recommend that if you're going to be in the AI business, I think this is a really good way to start from the basics. I think that if you're in high school right now and you've got a computer, I think this is your first assignment. Okay, that's 8 to 20 hours. We're only going to be together for maybe 80 minutes the most. What happens if you really, really want to learn AI engineering? What we're talking about is we're talking about VJ Reddy. VJ Reddy created this course called Machine Learning Systems. It's about 80 to 160 hours. What it does is it goes past the AI learning process and it gets into the AI engineering of all of the hardware and how all of that stuff works together. When we're doing AI engineering, you'll hear about these data centers that are being created at this point. Those data centers are a lot larger than all of the data centers we've discussed in the past. But you can hear about the billions of dollars being spent in those areas. The reason is that this consumes hardware very differently. And how we interact with that hardware is incredibly different. And we'll talk about that more in the other sections. But if you really, really want to learn AI engineering, that's not what we're doing here. We're doing machine learning principles and practices. Then these are the two places to go. You start by learning how to build a model in a little toy model, which is really cool. Sebastian does a really good job of that. And then you can go over to VJ's side of things and learn about it from an engineering principles standpoint. And I want to thank both of them because they helped me to get better at what I'm doing. I'm doing it a little bit differently. Okay, so why do you want to deploy machine learning? Well, because everyone said so, because it's the nice, bright, shiny thing. That's not a good reason. We're going to determine the business reasons and how to build metrics for all of this. So you ask the question, what is your mission? What is your mission, okay? What's the business reason? And in all these cases, what we're doing is we're figuring out whether we need machine learning for our organization. I know for me, in my organization, I've actually had some new programming built over the past year and a half. And as a percentage of learning machine learning and using AI, it's probably about 15 or 20% of the code. But that 15 or 20% is really valuable to me as long as I've been specific. Normally, in a class, I have a little section at the beginning of each one of the classes where I talk about AI and how it impacts the topic. But wait a minute, this is the machine learning principles and practices, so how can that fit in? Well, it really can't. We'd have to go into the other sections. But I wanted to talk about the course additions that I've added to all of my courses. So if you're watching these recordings in the various outlets, you're going to get some different stuff. I've created a prompt per mind map that I've added into each one of my mind maps. To find that, you can either go to the place where you got this from and it'll be sitting there, like the mind map will be a part of the course, or you can check my errata page for each one of my courses, and you can go to expandingsecurity.com to actually get those mind maps if you're a part of those courses, if you have access to those resources. So that'll be there for you. Okay, so what is it that I've given you? Well, what I did was I created prompts for you so that you can take the quiz in an AI fashion. You have a frontier model that you're using, or even a local model if it's fairly robust. You can take my prompt and drop it into your chat window, and it will offer you a quiz based upon the discussion or the topic that we're talking about right here. And it goes further than that. And what's nice is the quiz is yours. You can take it, and you can take it as many times as you want. You don't have to subscribe to anything with me. It's free if you've gotten to the resources, to the mind maps. There's also another piece inside of here, which is what I call your personal course progress report. And it comes in two flavors. The first flavor is you take the quiz and it gives you an output, and it'll give you a summary of what you should be learning, where you should be going, and it'll reach out to all the resources and all the links inside of the course. So if you're really not good at this and you explain this the wrong way, won't go ahead and say, here's some generic source. It'll go, what's Dean's source? And we'll give that to you and say, here, use this, because I've done the research on the sources that match up with the content of the course. The other thing is that there's a little string at the bottom. And that vector string that I have at the bottom on my website, you can actually, if you log into the website, you have an account there, you can drop that string in, and over time you can keep on dropping those strings in, and it'll give you kind of like a progress report overall for cybersecurity. So I hope you're interested in those things. If not, sit back and watch the rest of the show.